This session we're going to look at lessons 87, 88, and 89. In lesson 87, we're going to look at more identities. You're going to need to go on and write these down. We've got a lot that we need to write on the board and have for the rest of the year. But these are more sine and cosine. And then you have some more tan identities that we need to write down. Now, in this problem, we're going to mix these proofs with actual work that we have to do. We can look at more of these in class, but let me introduce the concept to you. They give you a problem. They say solve for sine theta plus pi over 4. And the way that you're going to do that is you're going to use one of these new trig identities that they gave you, this sine A plus B, which I wrote on the board. Sine A plus B equals sine A cosine B plus cosine A sine B. And what it is this right here represents A and this represents B. So anytime you see A, you're going to put theta. Anytime you see B, you're going to put pi over 4. But of course, we can go ahead and convert pi over 4, multiply it times 180 over pi, which we know that is 45 degrees. So instead of pi over 4, we have 45 degrees. But sine A plus B is, once again, in place of A and B, we're going to put pi in 45, or theta in 45. So sine A, what's A? A is theta. So anytime you see A, you're going to put theta. Cosine B, what's B? B is 45 degrees. Plus cosine A, whenever you see A, you're going to put theta. Sine B, whenever you see B, you're going to put 45. Sine theta, we don't know. We're just going to leave it as sine theta. Cosine 45 is root 2 over 2, which is 0.707 when you put it in your calculator. Plus cosine theta. Sine 45 is root 2 over 2, or 0.707. So the answer to this problem, when you factor out a root 2 over 2, is sine theta plus cosine theta with a root 2 over 2 factored out. So this is the answer to that. Not real difficult math-wise, but you're using these trig identities to solve for stuff. They're going to give you more of these, and we can look at this. But this is the general concept of lesson 87, is the sum and difference identities, which you can see, sine A plus B. And then there's more of them that I put on the page. And then tangent identities, which you need to write down. Now let's look at lesson 88. Lesson 88, we're going to be looking at some exponential growth here. You're going to need this formula of AT equals A0 e to the KT, E being our LN button on the calculator. AT is amount over time. A0 is amount when it was at 0 at the beginning. We could look at something like growth of an outbreak or decay over time or whatever. K is a constant, which we will be solving for, and T is time. So let's look at this first deal here. It says the number of bacteria present at noon was 400. So patient 0 is 400. Amount at 0 is 400. 9 hours later, the bacteria numbered 800. So the amount over time was 800. What was the time? It was 9 hours. The constant we're going to have to solve for. Then they'll give us the next set of numbers once we know the constant, and we got to solve for that. So we can divide both sides by 400. So 2 equals e to the k 9. We will take the e of both sides, and whenever we do that, the e of 2, then we'll be left with just K9 over here. The E of 2 is 0.693. Divide both sides by 9. And K is 0.077. So that's our constant, 0.077. So we use that. So we have AT equals A0. E to the 0.77 is our constant, our 0.077. So let's get the second scenario here. It says, assume exponential growth, find the number of bacteria present at noon the next day. So at noon the next day, so at patient 0 was still 400. e to the 0.077. This would be 24 hours later, and so they won't amount over time. This is what we are solving for. You simply put that into your calculator, and you're going to get 2539 bacteria. All right, this is how to use this formula in order to solve for this over time. We can look at more of these in class, but this is the concept on how to solve this exponential problem. In lesson 89, what they're going to do is they're going to give you, it's ellipse part 2, and they're going to give you some stuff, and you have to write the equation of it. And it says the standard form, write the standard form of the equation of the ellipse, whose vertices, the vertices are positive or negative 5, comma 0, and the foci are positive or negative 4, comma 0. Now, what this is you're going to have 4 and you're going to have 5. So it's going to be an ellipse that is obviously horizontal like this. And this is the foci, and it's 4. The whole thing is 5. I mean, it's negative 4, whatever. But what it is, if the whole thing is 5, you're actually going to make a triangle with the foci, and the vertex is also the same as the hypotenuse here. So you can use Pythagorean theorem in order to find this missing deal. So 25 equals 16 plus b squared, subtract this, it's 9 equals b squared square root. So positive or negative 3 is the b. So this is the other vertices here. Now this is going to be easy to figure out. Remember an ellipse, it's x squared over plus y squared over equals 1. So whenever x is 0, what is y? Y is the up and down. It's going to be 3 squared, which is 9. When y is 0, what is x? Remember, this was 5 all the way to here, so it would be 25. So that's how you would come up with the equation of an ellipse. So that's it for lessons 87, 88, and 89.